All right, this is the third part of this section, so it took us 3 days to get here.
How many is there?
But the one day was a short day anyway, so this is the last one of 3-4. Okay, so it's 3-4C, and it's called slopes. This is probably something you learned in Algebra 1. Did you do slopes, equation of a line? Y equals what?
Y equals mx plus b.
Mx plus b, right. See, you know stuff.
That should not be.
All right, here we go. So you do know a little bit about this, so I'm not going to take a whole lot of time, but I will explain it. So let's talk about what a slope is. Uh-oh. Okay, it's working. Thought it wasn't going to work. Okay, here we go. Everybody look up here. Noah, you're not listening to the thing I'm saying, okay? Because I've asked you to everybody look up here and listen, and you just keep on talking. All right. So this is a slope. You know, by my, I don't know, have I shown you a hiking video yet? I don't think I have in here, have I? Well, anyway, I used to hike a lot. But a lot of times you walk up the mountain, right? You got to walk up the mountain, and it's got a certain slope. And sometimes it's steep, sometimes it's not so steep. This doesn't look that steep, does it? All right, so there's me right there with my backpack on. There's my arms and my poles right there. So that's me. All right, so if I go up the slope from left to right, when we do slopes, going up is a positive slope. If I was up here, whoops, come on, there we go. If I was there going down like this way, my backpack right there, and I was going down like this, then what? That'd be a negative slope, okay? So from left to right, if I go up, it's a positive slope. If I go down, it's a negative slope. Now, the slope's going to be different depending on how steep the line is, correct? Or how steep the mountain is. So if I was here, this would be a lot steeper, so I'd get a different number here. So how do we determine the slope? Well, I'm glad you asked. We determine the slope by how high up you go compared to how far over you go. Did you hear what I said? All right, so it's a comparison. So a comparison is a ratio. A ratio is a what in math?
Fraction.
It's a fraction, exactly. Okay, so slopes are fractions. They're always a fraction. Even if the slope was like the number 4, that's still a fraction, correct? All right, because you could write it 4 over 1, right? Or 16 over 4, or 12 over 3. Everybody got that? Those are all equal to 4. 16 divided by 4 is 4, right? And 12 divided by 3 is 4. All right, so it's a comparison. Let's see if I can guess right. It's probably about right there. We'll see how far off I was. Yep, I was off a little bit. That's okay. Do this. So it's a comparison of how far straight up you're going compared to how far across you're going. Do you see that? So this slope, right, it's probably not all that steep because I'm not going up as far as I'm going over, right? What about this one, though? If I started here and I went straight up, that straight up distance looks, oops, let's try to keep this, there we go, gotta let go of that first. And then if I go this way, I was close. Oh, goodness. Okay. All right, let's just drop this down a little bit right there. All right, so this one's quite a bit steeper. Why? Because the up and down direction is a lot bigger than the going across direction, okay? But that'd be silly to say up and down and across. So what is the up and down direction? It's the rise or the y direction, correct? And this would be the what? The x direction, okay? So it's y over x. Or, Natalie, you said it. What'd you say? Rise over run, all right? So that's what we do. Yeah, you've heard that before, haven't you? Yeah, that's easy. So rise over run, that's what a slope is. A slope is just a comparison between how high up you go and how far across you go, right? That could tell you, it depends where you start. Like from here, if I go up, that's what direction? Positive. And if I go to the right, that's what direction? Positive. So the comparison of a positive to a positive, which means positive divided by positive, is what? Positive, right? Everybody see that? All right, so that's a positive slope. Even if you went down, watch this, even if we went the other way, let's say instead of going up from the guy at the bottom, what about the guy at the top or girl at the top? Well, I said it was me, so it's a guy. All right, so what if I did that? Oh, I got pretty close that time. You get the idea. I'll just keep it like that. So what if I started here and I went down? Does that make it a negative slope just because I'm going down? No, it doesn't. Okay, because watch. What is this rise? This is a rise, and this yellow one's a run. Which direction am I going if I'm starting here? I'm going what? Down, so that's what? So that's negative, right? And I'm going to the what? Left, which is also what? Negative. What's a negative divided by a negative? It's positive. Still a positive slope, isn't it? All right, so it doesn't matter if you start at the bottom, go up, or start at the top and go down. If from left to right it's going up, you follow me? Left to right. If it's going up, then it's a positive slope. All right? This is also a positive slope, isn't it? So let's take a look at a negative slope. So this would be a negative slope. Why? Because from left to right, which way are you going to go? Let's say you put a ball, big old beach ball or something like that at the very top, bowling ball, okay? Which way it would go? Right, it would go down the slope. Now, of course, it would go down the slope the other way too, but left to right, what's it doing? It's going down, okay? And if you wanted to do the things that we did before, just use this. So watch. This would be straight up and down. Oh, why do I always let go of that first? Let's try this one more time. About right there. There you go. And then right there. Oh, that's pretty good. Getting better. So let's take a look at this. This is the rise, correct? And this is the run. Again, does it matter if I start at the top and go down or I start at the bottom and go up? Watch, because if I start at the top, which way am I going? I'm going down, correct? So that's what? Negative. And now I'm going to run to the right to get to this point. So which direction is that? That's positive. Okay, remember what we said? The slope is the what? I haven't even written that down yet. Yeah, it's rise over run. Okay, that's the slope. Slope equals the rise over run. So let's just talk about the signs right now. So what is the rise? So I'm starting at the top. What's my rise? Negative over what? Positive. So what's any negative divided by any positive? It's always negative, isn't it? Okay, so this is a negative slope. Everybody got it? Let's talk about two other ones. Okay, let's do that then. Oops. Well, they're all straight lines, right? So what about here? Let's say I'm hiking. This is me. Backpack, poles. All right. So if I'm going this way, what's my rise to get from this point to this point? Right, I don't go up at all. It's completely flat. So I'm not going up the hill at all. I'm not going down the hill, okay? So I'm going 0. So remember what we said the slope is? It's rise over run. So the rise is what? 0. How far do I run? I don't know. It doesn't matter, right? Let's just say x, okay? Okay, let's just put x in there. That could represent any distance. What's 0 divided by anything at all? It's 0. So a horizontal line, write this down, a horizontal line, I'll get to you in a second. A horizontal line, the slope is 0. And I'm tired of writing the word slope all the time. There's a letter that we use to represent the slope. You'd think it'd be S. Kind of makes sense, wouldn't it? But it's not. It's M. Remember y equals mx plus b? So we use M to represent the slope. I looked it up because kids used to ask me, actually not that much. You'd think they would ask more because M's a weird letter, right, to use for slope. Good question. I'm glad you asked. So nobody actually really knows exactly where it came from. They have theories on where the M came from because this goes back hundreds, if not maybe a couple thousand, more than that, years ago. All right. I don't know if it goes back that far because of the English language. I don't know how far that goes back. But anyway, it goes back a long, long time. All right, maybe hundreds of years. So they use M. Some people, I looked it up. You can Google it yourself. But I looked it up, and they think it possibly could come from like a Latin word, kind of meaning mountainous. I'm not sure Exactly. Nobody really knows. There's no definitive answer where they're like, okay, this is why we use m. Right? It just goes back so far. Nobody really wrote it down and said this is why we use it. But some people think it comes from a Latin word and it could translate to mountains. That's what I think of. I think of slope being M being mountains, right? Because you go up a mountain, and I used to hike all the time, so I always went up mountains. And so you can think of it that way. But it doesn't really matter as long as we know that the M means what? Slope. Okay, so this is zero slope. I get people to think of this all the time. I did a little bit of skiing. I wasn't like a big avid skier, but every once in a while, maybe every couple years or so, I would go skiing, maybe a couple times a year if I was lucky. And if you're on skis and you just stand there and it's completely flat, how fast are you going to go if nobody's pushing you, the wind's not blowing you? It's just going to go zero, okay? Because you're on a flat surface. Would you agree with that? All right, you're going to go zero. So that's kind of how I think that the slope is zero. Or you could think of this way. It's rise over run. So a horizontal line, you don't rise at all. That's zero. But you could run or ski or whatever, any distance, okay? And that's why I put the x here. 0 divided by anything is equal to 0, all right? What's another kind of line we haven't talked about? A vertical line. Very good. So let's do a vertical line. I got a story for that. You want to hear my story? It's kind of interesting, I think it is. Not on skis, no. That would be horrible. Okay, yeah, I'll tell you. It's not while mountain climbing, but I'll tell you. Just quit guessing, and I'll tell you in a second. But let's talk about this. Let's do the math first. Okay, look at it mathematically, and then I'll tell you a story. So if you started here and you wanted to get to here, remember, the slope is rise over run. Whoops, there we go. Again, let's just talk about the signs, positive, negative, or no, we'll talk about the distances, okay? So how far do you rise from here to here? Well, I don't know what that number is, but it's along which axis? The y-axis, okay? Remember, this was along the x-axis, so what did I call it? X distance, right? Horizontal distance would be x distance. So what is the rise from here to here? It would be what? It'd be y. It'd be y. No, it's not 0 because I did, right, from here to here. That's not 0 distance. That's whatever distance. You can use any letter. I use y. Why do you think I used y? Because it's going up and down to y-axis, right? It's vertical, okay? And then, so once I get here, how far do I have to run to get here? 0. What's any number divided by 0? You got a calculator? Do you have a calculator? Get it out. Even if you have a phone, I don't care. Even if you have a phone, get the phone out. Do you have a calculator on your phone? All right, put any number. I don't care what number you put. Don't put 0 though. Any number but 0. All right, any number. It says error, doesn't it? All right, or it might say something else. Syntax error or just error. What's yours say? Just error? Yeah. Okay. So why does it? Yeah, and basically what it's telling you is you can't divide by 0. All right, good. All right, you cannot. You cannot divide by 0. I'll give you a quick little explanation, then I'll tell my stupid story about me. And it's not that great. But I don't know, it was kind of cool. All right, shh, let me talk. So let's talk about, let's talk about dividing by numbers, all right? So like 12 divided by 3. What's 12 divided by 3? Do you remember when you were a kid, you used to be able to check to see if that was correct? Look at it. Yeah, 4 times 3, exactly. Okay, look. So if this was true, listen. If this was true, then 4 times 3 must equal what? 12. Would you agree with that? All right. I mean, you can do that with any fraction. Okay. What if you did this? What if you did 0 divided by 5? What did we say 0 divided by anything was? 0. Now let's do the check. Right? What's 0 times 5? 0. Does it check? Yeah, it does check. So 0 divided by anything. Doesn't matter what this number is. 0 times any number is always going to be 0. So that works, okay? Now, let's try it like this. Let's try number 3 divided by 0. You guys, a lot of you guys, most of you guys said it was equal to what? No. Before you put it in the calculator, what did you guys say it was? A lot of you guys said it was 0, right? So let's do the check. What's 0 times 0? Is it 3? No. It doesn't check, does it? Okay. Is there any number Is there any number, listen to me, come on, let's think. Is there any number times 0 that's going to give you a non-zero number? There's not. Because what does 0 times anything equal? 0. And if this is not a 0, this can never work. That's why it's an error. All right, so this does not work. It's not equal to 0. A lot of times we use the word undefined. Oops. You could use empty set. It's fine. But a lot of times they'll use this word, undefined. All right, it's just a nice, easy word that we can use to say that you can't do this. You can't divide by 0. So what is the slope of a vertical line? It's undefined. The slope of a vertical line, I'll just shorten that, vertical line, is undefined.
Would it be wrong to say 0?
It is wrong to say 0. Because what kind of a line has a 0 slope? No? What kind of line? Yeah, it's a horizontal line. It's right there in your notes, isn't it? Right? So a horizontal line has a slope of 0. 0 is something. I've had kids tell me, Mr. Hamrick, 0 is nothing. If I have 0 something, I have nothing of it. But 0 is something. 0 is on the number line. Okay? You can add 0 to something. You can subtract 0 from something. You can multiply something by 0. You can take 0 and divide it by another number. The only thing you can't do is take a number and do what? Divide it by 0. All right? So 0 is something. Would you agree? Yeah, it's on the number line. It is something. It is a number. All right? So an undefined slope is different than a 0 slope. 0 slope is horizontal. Undefined slope is vertical. All right? Here's my story real quick. I was in college. I was in the ROTC, Reserve Officer Training Corps, maybe. I think that's what it stands for. Anyway, it was kind of like Army-ish. It was like play Army. It wasn't like real Army. You didn't officially sign up, but I think if you graduated with ROTC, you were able to go to, if you wanted to go to boot camp or something for the Army, you could have like a higher rank or something like that. I don't know. I really wanted to be in the Marines. I actually went to a recruiting office when I was in college to join the Marines because it was back when, I don't know, a bunch of stuff was going on in the world, and I was like, oh, I want to fight for America. And so I went in the Marines, even took a test or two to get into the Marines, but then had to talk with my dad. My dad was very wise, still very wise, but he was very wise, and he said, you know, I'm proud of you for wanting to go in the Marines and all that. He says, but I really want you to think about what that could mean and all that. And there's a lot of people go in the Marines and live a great life and everything else. But yeah, at that point in my life, I don't think I was ready for it. I had a friend. The reason I thought about going to the Marines, I had a friend in college, and he was in the Marines. That's probably why I have this haircut right here, because he had like a, what do they call it, high and tight haircut. And I always thought it looked real cool because nobody else had it. Everybody else had, it was back in the 80s, right? So everybody had longer, type hair. Anyway, long story. I'm telling you too much. So I said, I'm going to join ROTC. That'd be fun. So and we would take different trips. And one time we took a trip to VMI, Virginia Military Institute. You ever hear of that? And it was a college. It's basically a college, like West Point or Naval Academy. It's a college for people that want to be in the service. So we did this thing called rappelling. So at first we were on a very non-steep slope like this. So here I was, and they were just getting you used to it. This was me. And then they had a rope. I don't know. They had like a tree. There's the tree. It had a rope attached to it, and then there's my long arms. Okay, then actually, no, it wasn't that way. It was this way. It was the other way. I'm sorry. What am I doing? So really, your rope was this way, and then the big tree was right there, or something. It held on to something. I don't know. That's a tree. All right, I'm getting terrible. I'm rushing. All right, so that's a tree. See the leaves, then the trunk. Right, there we go. So, and my arms were this way, and you'd actually go backwards, and you'd make like, they call it a Swiss seat. And so it's just a straight rope, and you put it under your legs and around you and all this kind of stuff, and you made all these knots. And what would happen is you'd go backwards, and you'd hold on to the rope, and to stop yourself, Because if you held a rope like this, it would just be completely slack and you would just fall down the hill, right? But you hold it like this and it kind of tightens up, and you let it out a little bit and it gives a little bit of slack, so you can just kind of scooch down the hill, still being attached to the rope. So it's kind of pretty cool. And that was easy, no big deal. That was just warm-ups. And then they took us to this. They took us to a sheer cliff. At the bottom of the cliff were all these rocks, right? All these rocks. I'm telling you. So it was my turn. Watch people do it. And so it's like, this was flat right there, you know. And so all these people were here. Some of these guys in VMI, some of these guys were Army Rangers. And an Army Ranger is like, you know, one of the top-notch people. Have you ever heard of Green Berets? I don't know, people like that. So they're like a special forces kind of thing, the Army Rangers. These guys did this thing called Australian rappelling. And they were like right here. And there's their boat, right? And they had a rope attached to them like this. But they were facing this way, right? Normally you face the other way and you go backwards. They're facing this way, and they would run as fast as they could and just jump off the cliff. I mean, everybody, like you guys, with your mouths wide open. I was like, what in the world? I was standing right next to him, and they're like, watch out, watch out. And he goes, doo, 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 and they jump, right? And they got the rope attached to them, right? So it gives them some tension. And then they would go, yeah, boing, boing, down to the bottom. That's what they would do. Oh, it's crazy. Boing, boing. That's the sound that it made. All right. Anyway, so that was not us. We were just kids that had never done it before, but that was crazy. I think they called it Australian rappelling or something like that. So this was me. All right. You watching? Listen. All right. So my arms were extra long arm that day. And so you had a rope attached to something, some pole or something like that. Right. And there was a lot of slack in the rope, you know, to let you down. But you would just let out a little bit. And you got to the point where you started, you know, going over top of the cliff. And so your legs were like this and your arms were hanging on to the rope. Okay? Well, the guy told me before you started going down, you had to be perpendicular. There's a good geometry word for it. You had to be perpendicular to the side of the mountain, right? And I know I was like this. I was already perpendicular. He says, no, let out a little bit more, little more, right? And so guess what's going to happen? So eventually my head was here and my legs were up there. So I'm completely upside down, just hanging on to a rope. And this had to be 50 or 60 feet high at least. I mean, enough if you fell, it would kill you for sure. You wouldn't have a chance. And so I'm here hanging on to a rope, right? This is a rope, all right? I'm hanging on to the rope upside down. And the guys, because I was like this, right? I mean, he thought I was like this, but I know I was like this. He says, let out a little more. So I'm going like this. This is my head right here, okay? I'm letting out. And all of a sudden, yeah, boom. And I'm upside down like that picture right there, all right? And the dude's freaking out. He's like, don't move. And they're getting all ready to come rescue me. And as soon as that guy starts yelling, everybody else that was in ROTC comes looking over the ledge, and I could see all these faces looking at me. I was like so embarrassed. I wasn't even scared because I was more, well, I mean, hanging upside down. It's kind of hard to stand up. Well, you're giving away my story. So I was straight up and down. Everybody's eyeballs on me. I was so embarrassed. I wasn't even scared because I was just too embarrassed. And I'm like, there's no way I'm letting this dude come and rescue me, right? Then I'd be like, that would be horrible. I think I should have just fallen to my death than have somebody rescue me. Nah, it's a little extreme, but you know what I mean. So anyway, I was like, there's no way. So I started kind of bouncing a little bit this is a side of a cliff, right? And I'm kind of bouncing off of it, and I finally got my feet, because it wasn't that easy. When you're upside down, it's not that easy to get your feet, you know, under you. So I was kind of boing, 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 and then finally I got like this, and I went down like that. And I got down to the bottom, and the guy's like, man, you had a rough start, but you got down faster than anybody else did. And I was like, yeah, I know. I said, I was so embarrassed hanging out. I said, I wasn't going to let that guy save me or something like that. He says, well, you did good after you got going. So anyway, that was my rappelling story. Why do I tell that story? Because look at this. If I would have fallen, I would have been undefined, right? They probably wouldn't be able to tell who I was. I mean, it was such a big fall. At least in my mind, looking back on it, it seemed like I was really high up. Well, maybe not that high, but higher than this building that we're in. I mean, it was like 3 times the height of this building, I think. So anyway, I would be undefined. There wouldn't be anything left, okay? I wouldn't exist, right? So the slope of a vertical line with that, all that story right there, it's my one time every year I get to tell this story, okay? I probably embellish it more and more, but that's pretty much how it happened, though. I mean, that's no lie. So the slope of a vertical line is undefined, okay? It does not exist, right? There's no way. Has anybody actually gone skiing at a ski resort, snow skiing? Nobody's gone skiing? So they label like the greens for like the real easy ones, and the blues are a little bit harder, and then the black diamonds, okay? Black diamonds are always the hardest. There's never a black diamond where it's straight up and down. The hardest mountain, the hardest ski resort ever in the world will never ever go completely straight down. Now, it might go like this, or it feels like that. It's probably not that steep, but you know, that would be, yeah, roller coaster can, but you're hooked in, you know, and that kind of thing. I mean, it goes upside down. But even something like that's pretty steep when you go skiing. This does not exist, right? It doesn't exist at a ski resort. So what is the slope of a vertical line? It doesn't do what? It's undefined, or it doesn't exist, right? There is no slope. There is no slope, and that's what you'll see a lot. You'll see either undefined or, oops, it's supposed to be an O, or you'll see a lot of books say it's no slope, all right? Everybody got that? So vertical line, just remember my silly story, all right? It's not silly. It happened to me. Almost died. So it's not the first time I almost died, but that's all right. So, well, that probably was the first time. After that, I became an adult and I went kayaking. There was a couple times I had some near-death experiences. All right, let's do, all that said, let's talk about slope. Let's do an example of it, all right? So here we go. I'm going to draw a little X and Y axis, right? We've done this already. We're kind of going to do the same thing that we did with distance formula and midpoint formula. So let's just put some random line right there. Technically, this keeps on going. All right, and so what do you want to do? You want to find, let's go blue, contrast well. All right, if I wanted to find the slope of this line, what I do is I pick 2 points. All right, and a lot of times they're just going to give you the 2 points. They won't even give you the graph. Sometimes they give you a graph, you got to find the slope. Sometimes they'll just give you the 2 points and you got to find the slope. So what do? We do the rise over the run. So you could start from the bottom, go to the top, or you could start from the top and go to the bottom. So if I start from the bottom and go to the top, I would rise this far, and then I would run. Let's change colors. I would run this far. Oops, I was off a little bit on that one. Let it match up. There we go. Okay. So the blue is the what? That's the rise. And the green is the what? The run. Remember what we did before? We gave this a point. We made this, let's make it blue. This is just some random point. It's just some point on the line. I don't know my numbers here or anything. I didn't put any grid marks or anything like that. So what would I call this point right here? It's our first point, so I call it what? X1, what? Y1. Oops. Y1. Okay? And what's this point up here going to be? Yeah, this is going to be X2, Y2. So what are we trying to do? We're trying to find the rise over the run. What's this point right here going to be? Let's do that in a different color. Did I click it? Didn't click. There it is. What's this point right here going to be? So that means how far over to the left did we go to get to this point up here at the top left? No? On the X direction. We went X1. Okay, so we went X1. Then how far up did we go? We went Y2. Remember we did that earlier? With distance and midpoint? There. So there you go. So, with all that said, let's do a different color. What color haven't I used? Yeah, just
Black.
let's go pink.
I like this color.
Yeah, black's not going to work on a black background. So, all right, so let's find the rise. Let's find the rise. The rise is the distance or the length of that line right there, isn't it? How do I find the length of that line?
Yeah.
I'm doing rise, so which letters am I using?
Why?
The y's, rise, up and down. So I'm using the y's. So I could call this what? Y2 minus y1. So that's the rise. What's the run? If I went from here to here, I'm subtracting the x's, right? So what would that be? That would be x what? 2 minus x1. I'm doing all that for this right here. We all know rise over run. And that's good. I mean, that's a good thing to know. We use that a lot. But we're going to use rise over run to make the slope, we'll put m equals, to make the slope into a little formula with x1, y1, and x2, y2, okay? So what is the rise? What do we say the rise was? It's in pink. In terms of x and y's. y2 minus y1. Whoops, come on, pen. All right, and what's the run according to the x's? x2 minus x1. That is your formula for the slope. So let's just put it right here. And let's just put an m in front of it. M equals. Now let's put it in a box. There we go. Shows it's important, right? Put it in a box. And that's your equation, your formula, I should say. It's not really an equation. It's your formula for slope. Now notice I put y2 minus y1. It doesn't matter. You could go y1 minus y2. But here's what's very, very important. Everybody listening? You could go y1 minus y2, but you have to, absolutely have to put the x's in that same order, right? So if you went y1 minus y2, what do you have to do with the x's? x1 minus x2. See, in the same order. Doesn't matter what order you subtract them in, but you got to subtract them in the same order, okay? So if I'm going to subtract this minus this, I got to do the same with the y's and the x's. You got it? So I could take this from this, or I could take this from this. But you got to do it in the same order. The x's and y's have to be. Because that'll change your sign. Depending on if you, depending on how you subtract it, it could be negative or positive. And in order to keep the correct sign, you got to subtract them in the right order. Okay, let's do an example, and we'll be done. Let's do this. Let's make it white. All right, so here's the example. Oh, they actually give you a graph, and they ask you to find the slope. So watch. Here's a point right there. That's 0, 2. And this point down here is 4, negative 1. 4, negative 1. All right, and they're going to ask you, let's go yellow, pink again. Here's a line that connects those 2 points. Everybody see that? So what are we trying to do? Not find the distance, we're trying to find the slope. Okay? By the way, distance, you can't find the distance of a line, and you can't find the midpoint of a line. You find the distance of a line what? Segment, and the midpoint of a line, segment. But this can be a line, all right? So this is a line, and I got to find the slope of it. How do we do that? Well, what's the formula? Oops. What's the formula for slope? Slope is, again, it doesn't matter what order. The book usually puts y2 minus y1. A lot of times when I teach it, I'll put the 1 minus the 2. But just make sure that you subtract them in the correct order. All right, it's really easy. All that said, I mean, I took, what, half an hour or whatever it's been, talking about all that stuff. I could have, in order to just do the problems, I could have said, this is what the slope is. Just plug it in. All right, I could have done that, taken less than 5 minutes. But I like I like understanding where this came from. All right, so that's what I'm going to do. All right, so y2 minus y1, or yeah. So this is my, it doesn't matter which one you call x1 or y1. It doesn't matter. Let's call that our x1 and our y1. Let's call this our x2 and our y2. It's a little sloppy. It doesn't matter what order, just subtract them in the same order. That's it. So which ones do you subtract first and put on top? The y's. Yeah, you could go -1 minus 2, right? Or you could go 2 minus -1. Whatever way you do it, just make sure you do the same direction with the x's. All right, let's go 2 minus -1. Is that all right? 2 minus -1. And now we got to go with the x's in the same exact direction. So if I started with 2, I got to start with 0. So it's 0 what? Minus 4. Okay? And this is positive 3. This is not 3 over 4. It's what? Negative. It's negative 3 over 4. Look at my graph. From left to right, it's going down, isn't it? So that's a negative slope. So my answer should be negative. Always look for that. Okay? The next problem is just as easy. They just give you 2 points. They don't give you a graph. Yes? The other way? Yeah, you can do that, but it's not a 1. It's a -1. Right, let's do it that way. That's good. I was thinking about doing that, but let's do it. We got 2 minutes left, right? When's this? Is it 5 or 10? This is 10. Oh, okay. The next class is 5 after. I wish I remember. All right, so let's do it the other way. So instead of this top one minus the bottom one, let's do the bottom one minus the top one. So again, you always have to do the y's, put it on top. A lot of people get confused because they do the x's on top. Why do you think that somebody would get confused and put the x's on top? Yeah, because x comes before y, and it kind of makes sense, right? But always think of what slope is. What slope? It's rise over run. Rise is in the what direction? The y direction. Okay, so make sure you do the y's first. So you could go what? -1 minus what? 2. And then 4 minus 0. Does that still give you the same thing? Absolutely. That's -3 over 4. It gives you the same exact slope. Okay? So no matter how you do it, you'll get the same answer if you do it correctly. Good? All right, let me finish this one up and we'll be done. All right, it says find the slope. Now this is not the end all and be all of this kind of problem. Okay, they're gonna ask you to do some other things very, very shortly. Do some other things, and just one step, one part of that problem is you're gonna have to find the slope. All right. So just finding the slope, don't think you've accomplished a whole lot just yet, because finding the slope is going to help you find other things. All right. It's going to be just one small part of some of the problems we're going to do later. So, and it's easy. It's really easy. So find the slope. I put m equals. I always start off with my little fraction thing and subtract the y's. It doesn't matter what order you subtract them in, as long as you subtract the x's and the y's in the same order. So what do you want to do? You want to go -4 minus 2 or 2 minus -4? Okay, 2 minus -4. Now, if I went that way, 2 minus -4, what do I have to do on the x's? I have to go 3 minus 1. I cannot go 1 minus 3 because I'm going to get a different sign. You'll get the same number answer, but you won't get the same sign, and that changes the value of it completely. 2 minus -4 is +6 over 2. Right, they are completely different answers. So 6 divided by 2 is 3. So what's the slope? It's 3.
Can I still write 3 over 1?
Well, if you did it, if you subtracted one direction and the other one the other direction, you would have gotten 1, 3 and 1, -3. Like right here. Let's say, this is not right, don't even write it down, okay, because I don't even want you to get confused. But what if you went 2 minus -4 and then you decided you want to go 1 minus 3? What's that going to do to your answer? It's going to change the sign of it. And that's a completely different answer, isn't it?
What if you did, is it okay to write it 3.1?
Yeah, because we did it up here, right? We did that up here, and we got the same exact answer. So let's do that. Instead of 2 minus -4, let's go -4 minus 2. Like, wait a minute, Mr. Hamrick, you said we're going to get the same answer, but you're going to get a -6 right here, aren't you? But what are you going to get on the bottom? If I went -4 minus 2, I'm going to go 1 minus 3, negative 2, which is still positive 3. So it doesn't matter whether you go y2 minus y1 or y1 minus y2. No, as long as what? You do both of them in the same order. Okay? That's 3-4C. All right, so your homework. I don't know. Here's what I assign. I don't know off the top of my head if it's just slopes or not. I hope it is. I mean, it's 13 to 22. Are they all slopes? Did I give you the wrong one?
It's 23 to 26.
Is it?
So we can do that.
Yeah, 23 to 36. Are they all slopes? Is it all slopes? That's my question. 23 to 36. These are so easy, though. It looks like a lot of problems, but it's not really. You're on the right lesson? 3-4C? Actually, this is B. This is not C. It's the third lesson, so you might have some midpoint and slope in there. I'm not really sure. You sure it says find the perimeter? 3, 4. Oh, okay. I understand why. On 32 to 34, everybody listening? The reason it says find the perimeter, what's the perimeter? It's just the distance around it, right? Just add up all the sides. Well, they give it to you in ordered pairs, right? It's on a graph. So you're going to have to find what of each side?
Slope.
No, not the slope. That doesn't help you find the perimeter, the distance. You have to use the distance formula, okay? So 32 to 34, yeah, you're going to have to find the distance. And 29 to 31, it asks you to find like all three things. Distance, midpoint, and slope. So yeah, so that may not look like a lot, but there's a little bit of work. All right. So it's a little bit of work, but you're honors kids. You can handle it, right? You're honors. Natalie, have a seat till the bell rings. Let's have a seat till the bell rings. No standing up. There you go. Love them. What's that thing sticking out of them? A clip. Okay. All right, have a seat till the bell rings, please.